Bloom is probably one of the more controversial post-processing effects that you'll find in games. Some people love it, some people hate it, some people think it's fine, mostly in moderation, as long as you don't overdo it. Anyway, this is what we're going to learn to do in GameMaker today. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and unnecessary visual puns. Let's talk about Bloom. So what Bloom exactly is it is effectively an imitation of the physical limitations of, like, photography and when you take a picture of something, if you have a very bright subject, all the light from the very bright area will sort of overwhelm the photo sensor and wash out the, like, surrounding pixels a little bit. This example is probably a little bit on the extreme side. This is the sort of bloom that people would have made fun of back in the day, but we can also, like, tweak the parameters to control how this looks. We get a fair amount of control over how the bloom effect looks. And we'll be doing all that today. So, let me jump over here to my actual sample project. So what we're going to start out with is just basically a series of pictures of flowers. And we're going to apply bloom effects to this. I've set up some debug overlays. I love debug overlays in GameMaker. They make it really easy to, like, test different parameters for effects like this. If you want to know how debug overlays in GameMaker work, I made a couple of videos on those when they came out a couple of years ago. They're probably one of my favorite additions in recent years. I realize that some people don't like it when I, like, set up debug stuff like this and, like, don't say what all this does. But all we really care about are these three values at the top here. These are the parameters that we'll be feeding into the bloom shaders later on in the video. So, before we start, there's a couple things you're going to want to know. You're going to want to know how shaders work, and you're probably going to want to know how to, like, do basic operations in shaders. This is going to derive a lot from how blur shaders work in particular, so if you've ever written a blur shader, you are going to have a much easier time with this. I've made videos on getting started with shaders and different effects like blur in the past, so if you want to learn more about that, I will post links to all those related videos down in the description. We're also going to make some use of surfaces, because this is an effect that we're going to compute in stages, and we're going to save the results of the intermediate calculations to a surface, and then we're going to combine them at the end. So if you don't know how surfaces work, you're going to want to know how surfaces work. Surfaces are great, you can do a lot with them. Let's see, anything else? We're going to do a little bit with, like, color theory stuff, but I think I'll just explain that as it comes up. We're not going to go, like, really too deep into color theory or anything like that for this. But shaders, blur shaders in particular, and GameMaker surfaces are probably the major things. So we're going to start by rendering only the parts of the image that are above a certain brightness threshold. So let me go and create a shader. Let's say SHD. We're going to call SHD bloom cutoff. We're going to ignore the vertex shader. This is a post-processing effect. This happens exclusively in the fragment shader. So the way that bloom is going to work, instead of just, like, blurring the entire image, we're first going to draw only... We're going to basically discard all parts of the image that are below a certain brightness threshold. So, for example, like, the background, the shadowy area of this image over there, we're going to discard. The, like, dark green parts of the leaves, we're going to discard. And we're only going to bloom the, like, the really bright parts of the image. Because, again, what we're really doing here is we're imitating the physical effect of, like, too much light overwhelming a camera's photo sensor. So to do this, we're going to want to take the brightness of a pixel. Let me say vec4 sampled instead of just going directly to gl_frag color. You can if you want, but I'm not going to. So for each pixel, we can compute the brightness. The easy, naive way of doing this is going to be saying float brightness is going to equal sampled.red plus sampled.green plus sampled.blue, and all that divided by 3. So just simply taking the average of the red, green, and blue color channels in an image. This is okay. This will work. You can use it, but probably more commonly and definitely more accurately would be to take a weighted average of the red, green, and blue. Because, for example, your eyes perceive the color blue with less intensity than the color green, and we're going to want to account for that. And the most common way that you'll see that done is by defining some weights, which we'll call here luma weights. And we're going to feed 3 magic numbers into this here vector3. And we can say float brightness equals the dot product of luma weights against the sample.rgb. The dot product is, of course, going to multiply each of the components of two vectors by each other and then add them together. So this is effectively the same thing as saying like sample.red times 0.299 plus sample.green times that plus sample.blue times that. I've made a video on Grayscale and GameMaker in the past. That is one of the related videos that you may click on if you'd like to learn more. Anyway, so this is going to spit out a value between 0 and 1, with 1 being bright and 0 being not bright. And we can say, for example, if brightness is less than 0.5, we can just discard this fragment. Otherwise, we can say gl_frag color is just going to be the sample color. So again, we're going to discard fragments that are below a certain brightness threshold, and we are going to pass on the rest. So if I go back into the draw GUI event, if I say shader set SHD bloom cutoff, shader reset when we're done. When I run this, we are going to see that we can take these pictures and we're going to have, like, the bright parts of the image are going to come through as you would expect, and the dark parts of the image are just going to be thrown away. They're going to be resolved to be black. So this is going to work on any of these images. Some of these are brighter than others. By the way, yes, I do realize that this is a little silly that I have this labeled red hot poker, but these are yellow. That's just what they call these flowers. They come in different colors. Unfortunately, none of our red ones are blooming at the moment, so we had to make do. Anyway, so more helpfully than just hard coding to 0.5 as the brightness cutoff, we probably are going to want to make that a uniform so that we can pass that to the shader as a uniform to the shader, and then we can like control it from GML. So we can say uniform float. Let's call it U. U_bloom cutoff. We can say if brightness is less than that cutoff value, we can discard, and then we can go and say U_bloom cutoff in GML equals shader get uniform, and we can shader set uniform f that bloom cutoff, and we can set the value of that uniform from GameMaker, and it would make sense to make use of the bloom cutoff value that we defined in this test objects create event. So let's go and do that. And now, when I run this, we're going to be able to decide how much of the that's not the right slider. We're going to get to decide how much of the image we want to keep and how much we throw away. So if you set the bloom cutoff to some very high value, then only the very brightest pixels are going to be saved. If we set it to a low value, we're going to be saving more and more of the original image. All right, so that's great. That's going to be stage 1 out of 3 of doing bloom effects. So right now, we are just rendering this directly to the frame buffer, but this is going to be one of those intermediate stages that I want to save to a surface instead of to just like drawing it to the screen as is. So I did go and define a couple of surfaces in the create event. As usual, when you deal with surfaces, before you draw to them, you're going to want to say if not surface exists, we're going to want to recreate the surfaces, because surfaces can evaporate if you, for example, resize the game window or minimize the game window or something like that. Like GameMaker surfaces do not persist through events that interrupt the display. So we're just going to check if it exists, and if it doesn't exist, we're going to recreate it. We can say surface set target. Surface brightness, that other one. As usual, when you set a surface target, you usually want to draw clear C_black if you don't want the contents of whatever was previously there to persist. Sometimes you want that. In this case, we don't. I'm just going to indent this between the surface set target and the surface reset target so that you, we can see visually where this code is grouped together. And if I just run this, we're not going to draw anything to the screen because what we're drawing is going to that intermediate surface and not ending up on the screen. However, if we wanted to draw a surface, surface underscore brightness, we could, and we would see the contents of the surface are what we drew before. All right, that's great. This would be a good time to do a git commit. Because that feels like progress. The next thing we're going to want to do, so this is going to be stage 2 out of the 3, is we're going to want to create another shader, and we are going to want to blur the brightness surface. So let me go and create myself another shader. This can be SHD bloom blur. And this is pretty much going to be a bog standard blur shader. So there's a couple of different ways to do blurs in shaders.
Hey.
I'm going to go with the simplest version, and we're just going to take the average of adjacent pixels. We're not going to do like a Gaussian blur or anything where we like weight the influence of all the neighboring pixels by how close they are to the sampled to the source pixel. Let me get rid of this. We're going to start entirely from scratch here, and let me go create a for loop. So to start out with, the same way that I hard-coded the brightness cutoff in the other shader, we are going to just hard-code the blur radius, the blur size, the side length of the box blur, if you want to be specific. And to do this, I can say for float I equals negative 5.0, I is less than or equal to positive 5.0, I plus equals 1.0, and we're going to do a double for loop. Yes, I know in a shader, that's pretty extreme, but I'll get around to slightly optimizing this later. So we are going to create a basically an offset vector 2, which is going to be like the distance away from the source pixel. So like -5 relative to the source pixel. When you start the for loops, it'll be, and then the for loops will iterate over a 5 by 5 pixel region around the source pixel, or I guess really it'll iterate over a 10 by 10 region around the source pixel. So instead of being in like an integer number of pixels offset from the like source fragment that we're looking at, the offset is going to need to be in texture coordinates, which really means that we're going to need to divide I and j here by like the dimensions of the texture, or in our case the dimensions of the surface that we're sampling from. And previously in GameMaker you would have had to have passed like the dimensions or the texel size to a shader as a uniform, but starting a couple of years ago, we can figure that out in the shader using something known as partial derivatives. This is probably another one of those things that I should have cited as a prerequisite at the beginning of the video, isn't it? But the okay, how long do I want to spend explaining df dx and df dy? So the functions df dx and df dy, capital F, lowercase everything else, these are known as partial derivatives. This is not like hardcore calculus, but it does verge on it. And this will give you the change in a value over the span of an image when you run the fragment shader on an image. And this can be used for a lot of things. In our case, we're going to be using df dx, df dy to basically compute like how big each texel is in texel space. And we can use this line of code to figure out like each texel is going to be like 1 over like 1366 by 1 over 768, I think is the size of the window here. And we can use this to convert a number of pixels, like distance in pixels, to a distance in texel space by multiplying vec2 I and j by texel size. Okay, hold up, it's me from the future. So if you look closely at this line, it says dfdx v underscore v textcore.x, dfdx v underscore v textcore.y. This was a copy and paste error. The second one should be dfdy dot v underscore v textcore.y. You will see that come to be a problem in a couple of minutes. Again, I don't want to spend too much time on partial derivatives here, but they do get the horizontal and vertical gradient of a value over an image. And the horizontal gradient of the vertical text coordinate is going to be 0, so Well, let's just say that if you look closely at the image that it produces, see if you can spot the error before I do. Anyway, back to the video. This is something that you tend to do pretty often in shaders, especially in post-processing effects, but also you can use it for other things. Partial derivatives are great. I've got videos on that. The point of all this is that we can now say this is going to be an offset in texel size and texel coordinates. And if we were to say, for example, texture 2D from gm_base texture, and if our vector 2 that we sample from is going to be v_v text chord plus the offset, this is going to sample from a neighboring pixel. This is going to return a vec4. I'm going to call it vec4 neighbor. Actually, we only really want the red, green, blue. We don't really want the alpha. None of these images have any alpha, but still, we only really care about the red, green, and blue. And if we want to take the average of all the neighboring pixels to create a blur effect, let's say vec3, let's call it value. We can initialize this to a vec3 containing 0. In each iteration of this loop, we can say value plus equals neighbor. And then at the end, if we divide value by however many samples this is, we can also count that up. Float samples equals 0.0 in each iteration of the loop. Samples plus equals 1.0. We can calculate this analytically without having to manually like add 1 every time. But anyway, when we say value divided by equals samples, that's going to give us the average of all the pixels in each region. And we can say gl_frag color is going to equal, we're going to want this to be a vector 4 of the value and an alpha of 1. Okay, so that's going to be our very naive blur. We can say shader set shd bloom blur. All right, wasn't giving it to me in the code help drop down there. We can say shader reset when we're done. And this is going to give us a, you did not like that. Why did you not like that? Oh, huh. Neighbor equals texture 2D, all that, dot alpha. We want dot RGB. We want everything except the alpha. All right. I wasn't paying attention there. So now when we run this, we've got the bright part of the image, but it's going to be a little bit more blurred. We can, again, play with the cutoff value. If we set the cutoff to a minimum, some minimum, we've got most of the image, which is just like a blurry version of the image. If we increase it, we've got only the very brightest parts of the image. And that's being blurred. All right, so let's go and clean this up a little bit. Firstly, we'll start by not hard coding the radius of the bloom or the half side length of the box blur, if you prefer. And to do that, we can say float u_bloom radius or u_bloom size. I feel like people are going to get annoyed if I call it a radius, but we can substitute this in uniform float u_bloom size. We can substitute that in for the hard-coded, like, the hard-coded size there. And then we can, as we did with the first shader, we can go and fetch some uniforms here. What was it called? u_bloom size. Like that, we're going to want to make sure that we're fetching the uniform from the correct shader, because if you fetch a uniform from a shader that doesn't have that uniform, you're not going to get anything. And our bloom size value that we want to insert into the shader here is going to just be that value that I set up in the create event, and we are also controlling through the Debug UI. So let's run this. And that is going to give us a bloom that we can control to some degree. So if I shrink that all the way down to 0, we are going to not actually be really blurring this at all. We can play with the cutoff value, and we can decide how much we want to blur this. Again, this is not like an extremely high quality blur. This is not a Gaussian blur. If you wanted to, if you really wanted a really good blur, you would, instead of just like straight up taking the average here, you would weight the influence of pixels based on how close they are to you. This is also getting to be, let's say, very expensive. I don't know if you can hear my GPU fan spinning in the background, but if I open up Task Manager, we can see that just running this on a single image is eating a good chunk of my GPU here, which is heavily dependent on the radius of the blur. Again, I will get to optimizing this later in the video. Okay. Next, just as like a little minor thing, instead of just figuring out the number of samples by setting it to 0 and incrementing it every time the loop goes around, what we can do is we can actually just compute this based on, like, we know the size of the box that we're blurring. It's going to be basically 2 times the bloom size parameter plus 1, and that value is going to be squared. So if we say power 2.0 times the bloom size plus 1 raised to the second power, that's just going to be our the number of samples that we have in this doubly nested for loop. We're going to get the same image doing this, but alright, yeah, shaders are very picky about like whether or not 1.0 is the same thing as just 1. Yeah, this is the same thing we had before. Alright. Lastly, at least for the bloom here, we are also going to want to put this on a shader. So in addition to the brightness surface, we're also going to want a blur surface. Let me just call this surface underscore blur. And we can give this basically the same treatment. We're going to want to verify that it exists before we do anything with it. Otherwise, if the user minimizes the game window or tabs out or something like that, it's going to evaporate and then the game is going to break when you try to draw to it. We can say surface set target surface underscore blur, like we were before. Surface reset target when we're done, like this. Let me space that out the same way that I had it up above. This is going to draw this to the second surface. If we just run the game now, we're going to do all that work and get a black screen, which isn't great. So we can actually draw that blur surface if we want to see what it looks like. For like the third time, this is going to give us the same thing that we had before, just in a little bit indirectly. And that is going to be the second stage of computing bloom. Fortunately, that is most of the work. The last stage is not going to involve creating any new shader. All that is actually going to be involved in the last stage is going to be drawing the original image like this, with the GameMaker default shader. We are going to set the blend mode to additive blending. And we can do that by saying GPU set blend mode BM underscore add. When we're done, we can set it back to BM underscore normal. We are going to want to draw the blur surface on top of the original image with additive blending, and that is going to give us the final effect of like washing out the extremely bright areas in these images. It might be a little bit more helpful if I go to one of the pictures with like higher contrast. Ooh, wow, that's intense. I haven't like finished implementing this, but if I raise the bloom cutoff, we're only going to get the bloom on like extremely bright parts of the image, which might be a little bit less harsh on the eyes. That's still pretty harsh on the eyes. What about the spirea? All right, that one's better. So you probably want a little bit of control over like how intense that blur is, and there's a couple of ways you can achieve this. We can use the alpha argument and draw surface extended. So scale of 1 on both axes, a rotation of 0 degrees, a color, blending color of C underscore white, and let's say an alpha of bloom amount over here. And this should allow us to like dial down the bloom amount a little bit. Just using the alpha argument and draw surface extended when you combine them together. All right, that's definitely better than what we had before. Let's try some of these other ones. All right, so that's going to be the cactus. So as it turns out, like the background of this image is actually a lot brighter than the flowers on this cactus themselves, which I did not account for when I take this picture, so that might not be the best example. I think the Spirea is probably my favorite example of bloom in here, because it's got like the appropriate amount of like brightness and contrast to really let you see what's going on. And of course, we can make this, if you increase the bloom size, you're going to get like a more influence of the bright areas on areas that are farther away from the flowers. And if you decrease the bloom size, it's really just going to be the like the bright pixels themselves that get washed out. Probably a medium value, like 5. Like I said, the default is probably good, and maybe a it depends on the content of the image, but I'm gonna say a bloom amount of like 1/4 is probably where you can really see the bloom effect without like going blind. These don't look real when I throw the bloom shader on top of these tulips. They were definitely incredibly bright, just like on their own.
Hey.
And when I throw this bloom effect on top of them, they kind of don't look real. All right, that's enough of that. Okay. So that is a basic bloom effect. There are different ways that you can tweak this. Like I said earlier, in particular, there are different types of blur that you can use. I am going to optimize this double for loop just a little bit. However, because I feel like this is not something that I really just want to leave as it is. So when you do a box blur or a Gaussian blur, usually, like, you can do it by doing a double for loop like this, but usually what you actually want for the sake of performance is to separate it into 2 stages. So we're going to go from 3 stages of drawing this bloom effect to 4. And we're going to first do a horizontal pass on the blur. So we are only going to blur it on the horizontal axis like this. Instead of saying the sample is equals like 2 times bloom size plus 1 raised to the 2nd power. We're not going to need to raise that to the 2nd power anymore because we're just doing it on 1 axis. We're not squaring it. I'm going to call this bloom blur horizontal. And was GameMaker smart enough to actually refactor this? It was. Alright, that's cool. So sometimes when you rename an asset in the asset browser, GameMaker will correctly update references to it like this, and sometimes it just won't. Let's see. When I run this, you know, this would be a good time for me to actually make use of these like test draw brightness, test draw blur settings that I included at the beginning. So this is just going to allow me to check a box in the debug overlay, and we're going to be able to see the contents of different the different surfaces. So we can go with the brightness surface and the blur surface. And now when I run this, I'm just going to be able to like check the box that says draw brightness or check the box that says draw blur. And this is still going to look blurry, but it's really, if you look closely, it's only going to be blurred on 1 axis. This chicken wire in the background, you can see that now instead of just being like blurry smudges, they're more like blurry lines. And you can also see the effect on other small artifacts if you look closely. And that's going to be a horizontal blur, and we're going to do the same thing later, but we're going to make a vertical blur. So if I duplicate this shader, and if instead of blurring it on the horizontal axis, so we're going to instead blur it on the vertical axis by switching around the I and J of the vector 2 offset over here. And if I go back to draw GUI, I am going to want to set up a 3rd surface. Let me call this surface blur H and surface blur V. And when we use that surface, we can reference it by name there. We can also check if surface blur V exists. Before we do anything to that. And now we're going to do a 3rd stage here. So we're going to surface set target surface blur underscore vertical. We're going to do this. We're going to do the same thing. We're going to want to update the references to the shader to point to the correct surface. It's going to have the same uniform, and the surface that we're going to want to draw is going to be the previous blur surface. So surface blur H, and then this is surface blur H is going to contain both the horizontal and the vertical blur. So when we draw like the final image, we're going to want to use that one. And down here at the bottom in my test draw, we're also going to draw that. So now if I run the game, we are going to have what we had before if I enable the blur surface down here. The chicken wire in the background still had a visible horizontal blur to it, which makes me think that I missed something, and it's probably like a copy-paste error. Where would that actually be? Feather does not like redeclaring a variable of the same name. Oh my god, the mother of all copy and paste errors. That took me like 20 minutes to find. I hate computers. I had dfdx on v underscore v textcore.y. I want dfdy, so this is going to get the vertical gradient of a certain value, so the vertical texture coordinate across the image. I want the vertical gradient, not the horizontal gradient, because the horizontal gradient is just going to be 0, and this shader was basically outputting a black image. Alright, so with that aside, I will probably draw an arrow on that or something in editing, just so that anyone following along this video sees that, like, when it happens. But if I check the test draw blur box now, that is going to draw like the image with a horizontal and a vertical blur. It's going to be done in 2 passes. And now if I like dial up the bloom size all the way to maximum and open up Task Manager, we can see that this is no longer using like 80% of my GPU. To do this blur here. Obviously, it's still not nothing. With a large blur radius there, because like blur isn't cheap inherently, but it is a lot more than it is a lot less than what we had originally, and it looks like actually that doesn't even change much when I turned it off completely. Interesting. So a good chunk of the GPU utilization here is just like drawing the image like 3 times. People love to argue about this. Creating and rendering multiple surface passes like this isn't free, and the exact performance hit of like bouncing around surfaces like this is different on different devices, particularly mobile devices versus desktop. But like with the double for loop, you would have been computing with a bloom size of 10, something like 440 texture samples for every pixel in the final image, which is considerably worse than just like bouncing around a couple of surfaces. Anyway, I suppose this leads us nicely into some closing remarks about the bloom effect. I am not going to pass judgment on whether or not bloom is inherently good or bad. I don't think that's a useful question to ask. Different people have different tolerance levels for how much is too much. So it is probably good in most cases to allow the user to go into the settings menu and like decide how much bloom they want. Whether or not they want to just turn it off completely or not. If you disable this effect completely, obviously you save a little bit of performance in addition to just not having the effect. There are a couple of other what I would call micro-optimizations that you can apply to this to make this perform a little bit better. I will let some of you optimization hunters figure out what those are yourself. There's nothing in here that's really going to save a tremendous chunk of time, maybe a couple of percentage points increase by thinking a little harder about how you calculate some of these values, perhaps. What else do I want? So I am using an additive blend mode when I combine the blur surface with the original image here. Other blend modes do exist. You might use something more like a screen effect instead of additive blending to combine these images in somewhat more interesting ways. I want to say, I can't remember off the top of my head, but I think the GameMaker blend mode named BM_max actually is either screen or very close to it. I might be thinking of something else. That's I can't say that looks. Oh, you know what? It's because when you do that, the setting the alpha to the bloom amount is going to interact with like the blending calculation in a different way. So if you're going to use another blend mode, you might want to set the alpha as like another shader uniform to the cutoff shader or something like that. Let me just do that real quick. What did I call the variable? I think it was just bloom amount. Yeah, bloom amount. And we can go into the cutoff shader and basically multiply the final output value from the cutoff shader by the bloom amount, and that's going to give us a That's going to let us use the screen effect without going too wild. Does that look better? That's up to you. All right, so the blur surface is still the same. It's just going to be a matter of like how it's blended. Anyway, I am going to end this off here. If you want the code for this, look for the GitHub repository down in the description of the video. Let me know what you think of bloom effects, and if you like them, if you don't like them, if you've done anything else with them, if you've used a different blur algorithm instead of just a box blur like this. In the meantime, I like to post videos on weird stuff you can do in GameMaker, so if any of this shader stuff or 3D stuff appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out Wizarducks and the Lost Hat, which is one of the games that I like to work on when I'm not doing YouTube stuff. Link to the Steam page can be found down below as well. I hope you all enjoyed that, and I will see you all later. Special thanks to Zenjamin, Squarecrow, Spy Games, Manta Ray, GameMaker, GameArt Indie, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.